FHIR simplified. Process, parse and report on HL7 messages with user Z segments. Import HL7 and healthcare data into FHIR with a Spark 3 Spring automated framework and graphical interface. Process healthcare files via IoT or data at rest, for simplified, quick and accurate processing. Our technology is comprehensive, so we deliver in days when others need many months. At the end of the migration of HL7 and an X-ray image automated into FHIR is a shortened recap of our HL7 parsing, encryption, query and reporting with even user Z segments. Here we see a raw HL7 message. We can process raw HL7 or HL7 parsed into JSON or XML into FHIR, encrypted. Now we are seeing how Big Data Revealed's graphical interface allows the user to select a source for HL7 messages, again in raw, XML or JSON formats reside for processing into the FHIR via their APIs. Big Data Revealed is a Spark 3, Java, Spring Framework application. Next, the user may select one or more healthcare documents, videos, images or most any type of media to be imported into the FHIR environment. In this case we are migrating a chest X-ray. Here we see the Big Data Revealed application securely encrypted the HL7 messages as it will all capable healthcare documents and images, within FHIR. Now we have run a query using the FHIR API and viewing the HL7 message segments for patient 1, as it now resides in MySQL in the FHIR environment. As we see, all the information has been successfully imported in from our HL7 input we selected. Here we see the binary representation of the chest X-ray we imported into the FHIR environment. Here is the actual image of this chest X-ray that was stored for this patient. Here is a more detailed look again at the patient's HL7 messages, segments, and details of the HL7 messages. Here we see several of the HL7 segments with all their detail that was delivered from the raw HL7 message via the Big Data Revealed and FHIR APIs. Again, Big Data Revealed stores all healthcare personal information encrypted, when the data types are capable of encryption in the FHIR environment. Here is a quick recap of last week's video on the HL7 processing of parsing into JSON, cleansing, secure encryption, and user selection of results for user query and reporting. Video of automated, advanced healthcare records trends with HL7 2.x through 2.8 and version 3, plus C, user segments, and HIR. The shortage of expertise and complexity to delivery is resolved. We have automated the flow of HL7 messages from the originating raw feeds to parsing into JSON or XML, repairing into JSON, graphical presentation and hard copy reports and exporting into FHIR. Into the segments and values including the occurrences. Here we are seeing a quick view at the existing segments and values for one specific company Big Data Revealed. We allow storage of segments and their values for each separate company in which you take in HL7 message feeds, so quick in processing, added accuracy, establish reporting and the export to HIR and other target locations for encrypted company-level HL7 messages. Here we see 1, Z, segment. Z, segments are for user-defined segments. These segments are processed, parsed, reported on, migrated to FHIR. FHIRs are all HL7 standard segments. No, we are showing the creation of a new user-created, reusable, collaborative HL7 company with segments and columns within the user-defined segments. First, we are adding according to the input schema for this new company a couple of the standard HL7 segments and fields that most of you are used to seeing. Now we will add a user-defined special segment using the standard Z character at the front of the new name. This allows the HAPI open source parser to recognize this segment as a user-defined segment and process accordingly. These segments allow organizations to customize the data they need to pass along to other healthcare organizations, and the storage of these schema changes allow for Big Data Revealed to report online and in hard copy this user-defined healthcare information. Here we are viewing a raw HL7 feed that happens to have a user-defined Z segment type. Though it is the only unencrypted data in our feeds, we can read unencrypted input feeds or encrypt the feed prior to processing of the HL7 messages. Now we set up to process the HL7 input messages by pointing on the company big data revealed to the HL7 source path and select the location to store the HAPI parse JSON results for big data revealed to continue its processing of repairing, encrypting and prepping the HL7 messages for users to select the segments and data they wish to report on from the graphical interface and hard copies. Now that the process has completed to parse the standard and user-defined Z segments into JSON, we can see that BDR has stored these results securely encrypted. Now the user selects the files in which the HL7 messages are stored in which the user desires to report on. Then the user will begin to select both the user-defined Z segments and values, then the standard HL7 segments and values the user also wants to report on. Now the user selects the files in which the HL7 messages are stored in which the user desires to report on. Then the user will begin to select both the user-defined Z segments and values, then the standard HL7 segments and values the user also wants to report on. Now the user selects to run the query and reporting process. Clicking on the view, we can see what segments and values we requested for our process. Now that the process is complete, we are viewing the results in a query and we see that the Z user segments are also present in our query results. If there are multiple paging, we can view any pages, and for large volumes of results we have server-side pagination to make viewing in seconds. The user can optionally click on the export icon and BDR will send a CSV file to the user's device for additional or later reviewing. Here we see the storage of the user-created query, for it can be recalled at a later time. As we see, though, the query results are stored securely with encryption as it is for all the BDR HL7 processing. Now we are viewing the storage of the HAPI parsed HL7 segments along with the user-defined Z segments. As we can see, all the data is securely encrypted, again as all staging of BDR where BDR has control is kept secure and encrypted. Here we see that BDR stores metadata for the lineage of the processes that are submitted and ran against the HL7 messages, as well as BDR has always stored metadata and lineage for processes that are run and access into the BDR application. In the real world of healthcare, the volume of HL7 messages can be vast, making it difficult to find what users are searching for and necessary for their delivery. BDR allows the query results to be searched by the values of the segments, including Z segments and values, along with all other field results reported on, for quicker and accurate viewing. HL7 transactions are encrypted and stored as a JSON file in a data lake file. We parse the HL7 into JSON, prepare the data, then make the data available for reporting. You have seen our automated HL7 processing, parse and encrypt HL7, query and report, then export into FHIR. Our watcher identifies new files that arrive via IoT, or data at rest. We handle user-defined HL7, Z segments and values, encrypt HL7 data immediately upon receipt, parse HL7 into XML or JSON, store as encrypted HL7. Our graphical interface allows selection of segments and columns for query and reporting. Report results and HL7 data remain encrypted through the importing of this healthcare data into FHIR. Raw messages and healthcare data protected from start until the end of reporting and importing into FHIR, with encryption. Big Data Revealed's healthcare framework is in Spark 3, Java with HL7, HAPI, plus FHIR. Reach us at 847-440-4439.